Hello YouTube. So today we are going to be doing another update of my Biped robot project, which I have been making for a while now. So this is the robot as it is now. As you can see, it's mounted on a PVC stand. That is so I'm able to test the robot walking without it falling over, basically. So this is the circuitry of the robot. You can notice that there is a power circuit breaker. There are two green PCBs, which are custom motor controllers which I made, and shown below are the linear actuators and the relays used to control them. The gray ribbon cables are for data, and the red and black wires are for power. So here's the back of the robot. You can see that just the linear actuators, and then up higher are the gears, and then finally are the motors controlling the hips. So this is the control circuitry. It's basically just two Arduinos. I want to have the two Arduinos communicate with each other and have one of them control all the linear actuators and have the other one control the hips, as well as the positioning of the hips, as well as an accelerometer to balance the robot. So here's a video of the robot testing a walking motion. Though only the linear actuators are moving right now, I have not gotten the hip circuitry to work correct. So here's another video just showing the supply voltage. It's staying at around 12 volts. So here is just another picture showing the green PCBs, which are the motor controllers, and also shown as all the rest of the circuitry. You can see all the wires are kind of messy right now. I'm going to have to manage the cables, especially when I get the hips moving. The wires could tangle up. Notice here that this is a prototype for the motor controller. This right here, it's just 4 MOSFETs which have heat sinks on them. Also, there are 4 diodes there. That works as a bridge rectifier, and the purpose of that is to have all the currents coming from the motor when you turn it off to go to ground and not damage the MOSFETs. Yeah, those are the 4 MOSFETs. It's a standard H-bridge configuration. 2 N-channel MOSFETs and 2 P-channel MOSFETs will allow you to rotate a motor in 2 directions. So yes, this is the prototype circuit, and here is the schematic for this final circuit which I made on the PCB. You can see it has, right here is the wiring of the MOSFETs, and that is what actually controls the motor. And here is a basic logic circuit. It's just some logic gates which basically make sure the MOSFETs are not on at the same time so it doesn't short circuit. So here is a 3D model of the PCB, and once I got the PCBs in the mail, I soldered it together and it looks something like this. Notice the yellow wires. That is to fix it because there's an error in the PCB. So here's another video of the robot walking at a bit of a different angle. So here's a video where I am testing the motor controller, and it's just controlling a drill motor similar to the one using on the hips, and I'm controlling it using a simple thumbstick, and that allows me to control not only the direction but the speed of the motor. However, shortly after filming this video, that motor controller burned out. I believe it was drawing too much current or something, so that is an error which I need to fix on the final design. However, I've tested several motor controllers. They all seem to burn out when I was testing it at 12 volts. However, at 5 volts, the motor controllers seem to work fine. So I should be able to have speed control with that motor controller as long as I have it at a lower voltage, and that will hopefully allow me to control the speed of the hips, which is very necessary as the hips have to have a very precise motion to balance the robot. So hopefully in a future video I will fix the motor controller PCB, and I will be able to have an accelerometer to control the motion of the robot side to side, and as well I need to add either a potentiometers or rotary encoders to actually know the position of the hips of the robot at any particular angle. So I'll show that in a future update of this robot, but for now, goodbye.